Recording.
It's 6 o'clock. We're going to turn it over to Gordon to start class.
Yeah, okay. So let me first share my screen. So today we are going to do some basic things with a packet tracer. So before we do all that, we should first go and review what we learned yesterday, or the vocabulary. So the host is, again, just computers or iPhones, basically a hardware device that can connect to a network. Your IP address is your name in your network, and it has to be unique. And you can find your network name by using your AND function with your subnet mask and your IP address. A switch is the hardware networking device that connects the hosts to a network. So this will connect computers and phones together. Your router will be the hardware networking device that connect your different networks together. And another note, yeah, home routers, they are different from the one we will be using because home routers are built to be more convenient and easy to use. And then also don't forget the airplane analogy, where the host or the computers and iPhones will be the passengers. Your switch are going to be the waiting rooms. And then your router is going to be the terminal. And you can move from terminal to terminal to like different waiting rooms inside a certain terminal. And that's going to be your airplane analogy. So switches and routers, this is sort of a picture of what it looks like at the hardware point of view. And it is basically a computer that doesn't have a screen or a keyboard, and you can only do certain things about the network with it. So at the bottom left, you got basically, so this thing has LEDs on it. And these LEDs are signaling you its like status by it can either be like green for it is on, or it's not, or the LED is not on, then it's gonna, or your link will be off, and then it could blink plus pause to say other messages to you. Also, we got router memories. So, computers have memories, right? So router also got memory and has 4 different types of memories, which is RAM, ROM, and then NVRAM, and then flash. And you got the volatile or non-volatile. Basically, everything is non-volatile except for RAM. And this basically means if you shut down your router and then power it back on, volatile memory is going to get wiped out, and then the non-volatile won't get wiped out. So RAM is like your volatile memory, or it's easier to access, but it can get wiped out if you shut it or if you like to restart your router. And then your ROM is non-volatile. This basically has all the boot up instructions, your basic diagnostic software, and your limited iOS. And then NVRAM is your startup config file. So basically, what does it do when you start it up? And then your flash is also non-volatile. It's an iOS and other system files. So there are different ways to look at software. You got iOS and CLI. So iOS is the operating system for, no, wait, okay, yeah. So iOS is operating system for router or switch. Like Windows is the operating system of your computer. And then CLI is user interface or command line user interface. Like Linux, I don't know how many guys know what Linux looks like, but it's basically just lines of writing. So instead of a graphic user interface, which would be a Windows, which everyone I'm sure is comfortable with using, it's very easy. to use. User input certain commands to set up the network, because we will be using the command line interface for the packet tracer and setting up the routers and switches and stuff and computers. So what is a packet tracer? Well, packet tracer is a cross-platform visual simulation tool, and it's designed by Cisco, which is this huge networking company, basically, and that allows users to create network topologies and imitate modern computer networks. So hopefully most of you guys have Cisco on your system right now.
Did everyone enjoy the Halloween special?
No, Randy, only you did.
Yeah, try to mute yourself. Thank you. So let me pull up my packet tracer, and you guys could also do the same. Okay, so I'll give you all like, I don't know, 3 minutes to pull up your packet tracer. But if you're done, you could message me or something. I don't know. Also, if you have any problems in getting to packet tracer, you can also ask questions.
Okay, when students fire up the file tracer, Gordon, hey, I recommend you just go through all those interface, those funny icons, just tell people what is what.
Yeah, okay. Okay, it's been 3 minutes. Hopefully everyone or most people got their packet tracer up. So this is what the packet tracer looks like. It's pretty confusing because there are a ton of icons and stuff, but we don't need to worry about a lot of them. So for now, let's just look at this bottom row. So to the bottom left, we have all these multiple icons, which is if you like hover over them, you can see what they all stand for. So if I'm hovering over this stands for network devices, and end devices are basically just your hosts. You got your components. We don't need to worry about that for now. And connections, which would be like wires and such, and other things we also don't need to really worry about. So first, I'm gonna show you guys what like a home network would look like. So to find the home router, you wanna click on the network devices, and this brings you to this tab filled with a bunch of network devices. And then you go to wireless devices. So click on that. And then in this huge like catalog of a ton of different devices, there's going to be one device called the home router. And all you need to do is just click and drag to this blank canvas you got here, and you have a home router. So now that we got this home router, we can add our hosts. So to find our hosts, we go to end devices. And as you can see, we got a lot of hosts. We can add a PC in, or a laptop, or a smartphone, or a smart device, whatever they call it. And the phone will automatically connect to the Wi-Fi because we didn't even set a password to it, but we don't need to worry about that. This laptop, I don't know, there's this like old, it's a old version. So to have your laptop connect to your home router, you need to have some module inserted. So if we like zoom in to the computer, this is the on and off button. So before you remove or input modules, it's good to turn the computer off. And then there's the LED light underneath it. If it's green, it means it's on. If it's not green, it is off. So I just clicked on it and it's not green anymore. So the module is like right here. So you just click and then drag to here. And that just puts the module away. And then there is going to be a module here. And then we just click that and then drag it into the spot in the laptop. And that module basically lets the
Hey,
computer.
Gordon, I'm sorry to interrupt, but I think you may say a sub window, but at least I didn't say it. Maybe you're driving to a different portion of your screen, or maybe you only share the packet tracer window. I know
Yeah.
what you're trying to show, but I only say the main packet tracer window. I do not say the.
Okay.
Yeah, I do not say this. You must
Oh.
talk about that, right?
So yeah, I was talking about that. So basically what I did, there was a module here at the computer. And then this is the power on and off button. So you click this to power the computer on/off. And the LED light underneath it indicates if your laptop is on or off. So before you switch modules, you want to turn your computer off. So I already did that. And then if you want to remove your module, you just take your module out and then drag it over here. And then the new module we want to put in, which basically lets this thing wirelessly connect to our home router, you just want to drag the module over here at the bottom right of your sub window, and then just put it in the empty slot there. And then if we turn the laptop on and then close it and wait for a while, yeah, it will automatically connect.
Yeah. Okay. Let me add something here. I think most your kids are too young. I never see this kind of laptop. But if you're talking a parent, at the very beginning of the wireless Wi-Fi thing, it's not by default including the laptop. Instead, you need to sort of buy a actual module and put inside of your laptop. So that's exactly what Gordon did. I guess this software built maybe 10 years ago. They're trying to represent in the whatever the hardware in that time. So yeah, but for now, old laptop already have a built-in Wi-Fi device. So you automatically have that. But in here, you need to add in the necessary Wi-Fi hard drive, just in case you got vendor. You've never seen that, but yeah.
Yeah,
Go ahead.
so that's basically for old laptops. We don't do that stuff anymore, but it's good stuff to know. And for the computer, we need to use a connection, like a wired physical connection. So to get your wire, go over to this lightning symbol, that is the connections tab, click on it, and then scroll over to this black line, click on that, and then press your computer. And then you have a ton of ports, and we want to connect it to the fast Ethernet 0 port. So click on that and then drag it, or not drag, we'll click on the router, your home router next. And then just click on any of these gigabit Ethernet ports you want. I'm just going to do Ethernet port 1. And as you can see, it has that like green triangle pointing up and this orange dot. And this is basically just the status of your connection. So right now, because it's orange dot, it's not like actually connected, but if you wait a while, I'm pretty sure it turns green. Whoops. So yeah, that's basically what your home network would look like. It's pretty simple, nothing too complicated. And if you notice, we didn't use any switches at all because they just kind of screwed the switches over. So we can move all of this to the side, and then we can start doing like some sort of internet network system that would be at like a workplace or maybe your school. So again, you want to go over to the routers tab, and also it turned green, so it's connected now. That's a good thing. So we want to go over to network devices again, and then go over to the routers tab. And then we got a list of routers, and I will just pick the 2901 router because that's the one I normally use. And so yeah, we drag this router here, okay, and we also want to grab some switches. So we're in network devices, now click on the switches button and just grab any switch, I guess, or the 2960, because it's the one I grabbed. Okay, once you grab these switches, we also want some hosts. So go to end devices again, drag in some PCs. So we got all of our hardware stuff. Now we just got to connect everything. So go to the connections tab, click on the copper straight through or the black line, and then start connecting. So all these guys you want to connect the computers fast Ethernet 0 to your switches, because your switches are basically just connecting all your hosts together. And then you also want to connect it to the fast Ethernet ports. Doesn't matter which one, but connect them. Okay, this one, fast Ethernet 0, and then we connect that port to fast Ethernet 0/2. So we got this switch connected to these two hosts. And this is basically a network or small one. And as you can see, it takes time for your lines to actually turn green or your connection to turn green. So we can wait for that. And while that is happening, we can also connect the other computers to the switches. Okay, great. So these guys turned green and they are now connected. The switch is connecting these two hosts together. So this should, or PC1 should be able to ping PC2, and pinging is basically one computer sending the other computer a message, and then this computer sending something back. That is what a ping is. So we click on PC1. Click on PC1, go to desktop, and we got a ton of different icons. For now, we will only worry about, we'll click on command prompt, and this will open up your command prompt like a real computer. And then, oh wait, actually, I don't think I assigned. So yeah, to ping something, you also need to know its IP. So we're gonna check its IP of PC2. So right, you click PC2, you go to the desktop tab, and from here, you click onto IP configuration, and it does not have an IP. And I don't think PC1 has an IP either. Right. Okay, so let's just talk about the IP configuration tab while we're here. So you can notice there are two different options. We got DHCP and static, and there's also IPv6, which is basically just a different way of writing your IP, but we don't need to worry about that. So DHCP, it basically means it will automatically assign this computer an IP, but we're going to use static. So we're just going to set this IP to 192.168.0. .100 or something like that. And subnet mask, oh, okay, yeah, subnet mask is generally always going to be 255.255.255.0. So that's this IP address. We don't need to worry about DNS server or default gateway just yet, but we will go over default gateway soon. So now that we set that IP up, we can go to PC2 and do the same thing. And of course, IP addresses have to be unique. So we're just going to set this one to 101 at the end, and then subnet mask will usually be this 255.255.255.0. Okay, so now we got IP addresses signed. We should be able to ping each other now. So again, exit IP configuration with X button, go to command prompt. Okay, from here, just type ping and then the address you want to ping. In this case, we want to ping PC2. So that would be 192.168.0.101. And look, so that means it's working. So it's saying we're getting a reply from this computer.
Hey, Gordon, explain people what is ping is, what it does.
So ping is this computer, or PC1 will send packets to the switch, and the switch sends it to here. And then this computer will receive the packets, hopefully. And when it does receive the packets, it will send the packets back. And then if this computer gets it back, then that means they have a reply from 192.168.0.101, which is this computer. I think if I go to simulation mode, you can.
Yeah, basically ping is, it's kind of, imagine you call somebody, maybe the first message you talk to other people is, can you hear me?
Yeah.
And then people say, okay, I can't hear you. Something like that. It's just to make sure we can hear each other. Yeah, you may have set up network. That's the first thing you want to do. I mean, you make sure everybody can see everybody.
Okay, so I think the simulation panel will let us see what's happening. So if I ping PC2 and I let the simulation run, it's sending packets to switch, and then the switch is directing it to PC2. Then the PC2 gets the packet, and then it's a ping, so it's going to send it back to the switch, and then it's going to send it back to the PC1, and then we get a reply. That's basically how pinging happens.
Maybe you can show people what if you pin like some IP not exist, like let's pin that 120, something like that. Just show people what happened if you failed.
So the simulation panel, it's on the bottom right sort of your screen. If you click it, because we're only doing pings right now, we're going to go to edit filters and then uncheck everything except for ICMP. Because if you don't uncheck these things, you're going to see a lot of packets, and that's not going to be, it's going to be very chaotic. So yeah, uncheck every single one of these boxes except for ICMP. Once you're done with that, you can ping from PC1 to PC2. And once you do it, you got to press the start button or the play button on the simulation, and then the packets will start. Also, there's a bar at the bottom of this control panel looking thing. So if you click, and this bar basically controls your speed, and I just kind of put it here so it's not too fast, but it's also not too slow. And you just press the play button, and yeah, everything happens. So that's basically ping. So what if we ping a non-existent computer? We will, well, okay, so let's ping a computer that doesn't exist. So 192.168.0.102, and then it's gonna start pinging this. But because there's nothing to ping, it's gonna say request timed out, which just means nothing came back. And that means the ping has failed. And after like 4 times, also pinging normally will only send 4 4 messages to the other computer. And right here it says packets. We sent 4 packets and we received none of them, which means we didn't successfully ping anything. And of course, we weren't supposed to ping anything because if we did, that would be weird. And oh, I don't know what I just did, but okay. So these computers are connected, and we could also do the same thing with PC3 to PC4, but we cannot ping from here from PC1 to PC3 because they are not connected yet by a router. So we're going to connect them with a router. So grab this. We're going to grab this black copper straight through line again, and then just connect the switches. We're just going to use gigabit Ethernet 01, connect it to the router, and then connect it to another gigabit Ethernet port. And then do the same thing with the other switch, and then connect to the other gigabit Ethernet port. So as you can see, the connection is red triangles, and that is because the router isn't set up yet. And basically to set up your router, click onto the router, and then you get this sub panel. Now click onto CLI, and then this brings you to this really confusing looking command line interface, and just press enter to, well, press no then. Right, so press no first, or N, to just skip whatever that is, and then press enter again, and you should see this router and then the greater sign, and then you can type whatever you want. So once you reach here, you want to type in the command enable, and then this will change your greater sign to the hashtag or pound sign, whatever you want to call it. And basically this is just, it's sort of like permissions. So if you enable it, you can do more stuff with the router. And then we want to go one more level down, or we want to be able to do some more things with the router. So we're going to type in the command configure terminal, and then that should bring us to router, and then has config here, and then the hashtag or pound sign, and that brings us to the configure terminal place. So this router port that's connecting to switch 0, that router port should be gigabit internet 0. So to turn that port on, we need to type in interface, and also you can use tab to finish your whatever you want to type. So we're going to do interface and then gigabit Ethernet, and then the port number for that port would be 0/0. So enter that, and then we enter the interface command, if that makes any sense. Okay, so now that we are there, to set it up, we need to set up the IP address. So this is where default gateway stuff comes in. So we're just going to set the router IP address, or that port IP address to. So first, to set the IP address, first of all, you want to use the command IP address. IP address, and then you want to type in the IP address of the port that you want to set it to. So we're going to set it to 192.168.0.1. Doesn't need to be 1, but it's common practices to set this as 1, so might as well get into the habit of doing it. And then once you're done with that, type in the subnet mask that you're using, and we are using 255.255.255.0, so we are going to put that in. Okay, and then we enter the command, and the IP address should be set. And then to finally turn the port on, we just need to type in one last command, which would be no shutdown. Yeah, and no shutdown just basically means, so shutdown basically means off, and then no off is just on. So yeah, we set this IP address to 192.168.0.1. Our subnet mask is this. And then we turned it on, and of course, this connection will take some time to actually work. So we just configured the first gigabit Ethernet port. So now we got to configure the other one that's connected to switch 1. So to go to there, first we want to exit the gigabit Ethernet 0/0 port. And to exit it, you just type in the command exit. And you go back to the configure terminal mode. And then we want to go to the interface that has gigabit Ethernet 0/1. So we're going to do interface gigabit Ethernet 0/1. And that should bring us to gigabit Ethernet 0/1. And as you notice, this has finished connecting. So good job, me, I guess. And we're going to do the same thing. We're going to do IP address command. And we're going to name this one a bit different. So we're going to do it in 192.168.1.1. And then the subnet mask will be 255.255.255.0. Okay, that's great. And then no shutdown. Oh, shutdown. Okay, so this part's starting to work. And basically we have configured the router to work. So now we got to configure all our computers or hosts. So let's go to PC1. And we are going to go to the desktop tab and an IP configuration. And this is when we want to change default gateway. So default gateway, I think we went over this briefly last class. Well, default gateway is basically let's say the door to the waiting room in the airplane analogy. That's what the default gateway would be. And the door for the waiting room would basically be the IP address for the port right here that we assigned to the router. And we assigned that 192.168.0.1. So that is your default gateway for PC1. And because PC2 is in the same network as PC1, they're sharing the same default gateway. We're going to set PC2 default gateway to the same thing, 192.168.0.1. Okay, so that's that. So quick question. Can anyone tell me what the network name of this network is? And a quick reminder, to find network name, you want to use the AND function on the IPv4 address and your subnet mask. And to do that, you just turn them to binary. 255 is just going to be 8 ones. And then if you do the AND function, you should get your network name. So can anyone maybe take a guess if you're not sure, but try to find the network name? Okay, so I guess I'll take the silence as no one knows. If someone's working on it, make a noise now, because I am about to tell you guys. Okay, no noises has occurred, so I'm just gonna assume no one knows. So basically, the subnet mask 255, we can just convert that to 8 ones, which means nothing on this, nothing about 192 was going to change at all, because if we convert, we don't even know 192 in binary, because nothing will change because there are no zeros, if that makes any sense. Okay, and same, basically 255, your subnet mask is 255. That just means whatever is above it will not change. So same thing over here, 168 will remain unchanged. This 0 will remain 0 because of this 255. And then 101, 101 will change because we got a 0 at the end. And 0 just 8 zeros. And because it's the AND function, that means the final number of your network name will be 0. So the network name of this network is 192.168.0.0. That's your network name. So these computers, we haven't set them up. So we're going to go to PC3. We're going to go to the desktop tab, IP configuration. And as you can see, this has not been configured yet. So these guys are on a different network. So we're going to give them a different network name. So we're going to do the 192.168. And then because we already set up this network port to be 192.168.1.1, that basically means your network name will also be a 0.1. Okay, and because this host, we're going to do 0.1.100, and subnet mask will basically be this default gateway. We already set that up on the router, so 192.168.1.1. That is your default gateway. And we're going to do the same thing with PC4. IP configuration, set this one to the 192.168.1.101. Subnet mask will be that. And then the default gateway is going to be 192.168.1.1. Okay, so I think everything should be configured fine now. So another quick question. Anyone want to take a guess at the network name for this network? Okay, no response. Oh, actually, we do have a response. Yes, the network name for this network is going to be 192.168.1.0 because we are doing the AND function between the IPv4 address and then the subnet mask. So now we got everything configured. We can do the ultimate test, which is just seeing if PC1 can ping PC3/4. So we're actually going to go to simulation mode again, just to show you guys how or what's happening. So we go to command prompt in the desktop tab. Now we go to command prompt and then scroll down. And then we're entering simulation mode. So it's gonna block out, whatever. So basically we're on PC1, so we want to ping PC4, let's say. So ping 192.168.1.101. So we're sending some ping messages there. Okay, and then let's see what happens. Okay, so it sends the message from here and then sends it to the router. Yeah, I don't know what happened to the packet.
Did you set the IP of the PC3 and 4?
Huh? I think I set it up, right? Well, this is taking a while, so I'm gonna put the speed up.
Sometime the router not working the first time, but
Okay, so seems to be a bit slow, so we're gonna try to ping again, because yeah, sometimes it doesn't work the first time for some reason. So we're pinging again, and yeah, packet goes here to the router, hopefully here. Oh yeah, okay, PC4. PC4 receives the packet, sends it back to switch, which goes back to the router, which goes back to this switch, and then goes back to PC1, and then we receive the reply from PC4. So that does work, which is great, because that means I set up everything correctly. Yeah, so that's basically a very basic view of maybe like your workplace, how like your workplace is set up and all that stuff. Of course, it would be more complicated as it'd have more routers and more switches and obviously more computers, but this is basically it. So does anyone have any questions? Because this is really confusing the first time you go through, but you'll get used to it if you work with networking enough.
One suggestion add, for example, this is like a router plus switch setup. If you very likely the first time you try not working, if it's the case, just break it down. For example, in that case, for example, Gordon failed from PC1 to 4, failed. Maybe you can pin from PC1 to the gateway of the network 1, right? And make sure that working, and then pin PC4 to the gateway. Make sure that part is working, right? And then just always the break it down more complex problem to a smaller problem.
Yeah, so basically what he's saying is if we're pinging from PC1 to PC4 and it does not work, that means somewhere along the way our packet got lost. So because we already pinged PC1 to PC2, that means our packet can travel to switch 0, no problem, which means it got lost at router 0 or switch 1 along the way. So in order to test if either one of these work, we can just ping PC1 to the default gateway, which is here, or the router IP for that network. And if that works, then that means the router is good. And of course, you can try to ping from PC4 to PC3, test if switch 1 is working. And hopefully one of them isn't working if your PC1 to PC4 thing isn't working, because if it is working, then there's something else wrong. You could check your IP configuration, maybe. You could have configured the default gateway, or you just pinged the wrong IP address or something like that. So any other questions?
Did you have a chance to show the IP route?
Oh, right. So there's another command. Oh, no, not here. So if we go back to the router command line interface. So let's first exit the interface of the gigabit Ethernet 0/1, because we don't need to do anything with that one because it's all working. Okay, we want to exit configure mode, go back to enable mode. And then there's a command called show IP route. Oh, there's space. Yeah. And this command basically shows you this huge list of things. So basically this is like your codes for things, different types of connections you can have. Yeah, they're just different types of connections. You can connect to things in different ways. So we got our IP address with the connection below, and this basically just shows, this will show all of your IP. It's the routing table basically. And at the airport analogy, the routing table is the huge list of airplane statuses. So yeah, that's the routing table.
Yeah, it's kind of like in the airport, you look at that big display port, say, okay, where's my flight? Something like that. So there's a 2-person, there's a network .0.0 connecting what port. It's kind of like latest flight, it goes to port 0.1 at the gigabyte 00, which is a physical port. It's very similar to the airport, information board. Yeah, by the way, that's the most basic routing table, which is just direct connect. If you study more advanced stuff, there are different type. Like some of them can be very complicated, but basic idea is very similar, which is the type on the list of the code on the up section of that. Yeah, but that analogy of the airport still hold. I think this really help us for last year. We always use the analogy, and we kind of making sense of the very complex topology. Yeah.
Right. So does anyone have any additional questions? Did something like not, or did their setup not work? Anyone confused about what we did at all?
We were confused, but last year when we started this, don't feel bad you're confused, but just start with the simple one and keep doing thing. Yeah.
Okay, so it seems like no one has any complaints or any questions. So I guess you guys gotta go another 15 minutes early again. Oh, and also next class, we will be doing some other complicated stuff, but is there anything like anyone wants to review or wants to like learn a bit about? Okay, I guess not. So yeah, now you're 13 minutes. You guys get to leave 13 minutes early. Have a great rest of the day.
Okay, hold on. Give me 1 minute. So if nobody have any request for what we cover next time, the next time, which is the last one, we're gonna cover start to talk about the concept of VLAN, virtual line. Maybe is most confusing part in that packet tracer networking thing for us. But we're gonna start to talk about that and start like similar like that. Start with a simple case and introduce that and basically cover why we need it and how to set it up. Something like that. And we're gonna cover maybe some so far we just talk about the network itself, topology, some concept. We're gonna cover some in point of view of a security. We're not going to very deep, but we just cover what the security well, any computer network, I mean, computer stuff have a security concern, but what are we particularly on that network thing? We're gonna cover just overview of that will be our plan for next session. Again, maybe we start maybe 30 minutes or for packet tracer. So I highly recommend people get packet tracer ready. We can do set it up at the same time. I think it's a very efficient. Yeah. Yes. Please. If you can install that, it will help. Yeah. Okay, that's it.
Thank you, Gordon. Thank you, Jun.
All right.